Alright guys, so today I'll be showing you how to create a dust or ink-like effect. And here's something I shot on an iPhone 6 at 240 frames a second. It's a brush with talcum powder applied to it, and I'm just passing my hand across the bristles. And the talcum powder is being blown into the air and swirling around, almost like cigarette smoke. And this is just a type of effect I'm going to try to achieve inside of Maya, and I'll show you how to get this kind of behavior. So let's jump over to Maya. Now I'm using a slightly different layout, and I prefer to use a black background for this kind of stuff because it just makes it easier to see particles and fluids. So first thing you want to do is make sure you have Dynamics workspace toggled. So let's start by creating a 3D container with an emitter, and we're going to have it just be, let's see, I'm going to make sure, so we have a fluid shape and our emitter. So let's just go up and move this 10 units up. And in the fluid shape, I'm going to make sure I use a size of 20 by 20. Now let's just hide the viewport grid. And we can keep this fairly low res, just because we're not interested in using the entire fluid as our result. We just want to use the motion of it to drive the particles. So we can get away with using low resolution fluid. But let's keep it at, say, 30. And next I'm going to make sure that our emitter is just a little bit lower. Maybe -9 would be good, just slightly above the ground. And by default, we're just going to get something, a little bit boring. Now, and while we're at it, let's just have a long enough time range here to be able to see the result. Okay, next let's introduce some of that noise. Let's go up to our fluid shape, and we're going to go into the content details under velocity, and we're going to add in some swirl. And swirl is going to introduce a lot of turbulence or force that separates the fluid from its intended direction. So, it's kind of slow, and we'll definitely need to ramp up the speed on our emitter. So let's just go back down and add speed. Let's set the direction, and let's say our direction speed is 10. So the direction is just the direction we want the force to be aligned to. So we want to align it to positive y. So let's play this through. And let's add just a bit more density in this thing. So I'm going to increase this to value of 10, and we should get just a bit more activity going on in here. And I'll just add a little more velocity in here to speed up the fluid. And I might take the swirl up a bit more. I mean, once you're happy with the features, you can do things like Animate your emitter. So I'm going to just set a quick key here, and let's say at frame, let's say about at frame 50, we move our emitter up a bit. So let's just say that's something we like. And this is the motion we want to keep. Now we can just, increase our resolution a bit more and create the final simulation that's going to drive our particle system. And if you want to be able to see what's going on inside of this simulation, one thing you could do is turn on the velocity visualization. And you can get to that from the display options. And if you turn on velocity draw, let's set our draw length a little bit higher, and you can begin to see where everything is going. And we know, let's just shrink this down some. I'm going to turn on the draw skip so we can just see a few of these points to see where everything is going. And we get a sense that, all the particles are going to be pushed up, and then they're going to swirl around, and there's a lot of turbulence inside the system itself. So let's say we're happy with that. I'm going to go ahead and let's also turn off the display of the fluid simulation. So this way we don't see the voxels in the sim, so we can focus on just our particle system next. So I'm going to go to N dynamics. I prefer to use nparticles with this. You could use the standard particles as well. And I mean, this is the way I've done it before, but nparticles give you a little bit more better shading, and there are much more options inside the nparticles system themselves. So let's just go in here and create a nparticle emitter. And what we want to do is make sure that this emitter has the same animation as our old one, as our fluid one. So we start at -9, and then go up to 8. So you could parent these together, it should work. Yeah, we just want to make sure that this one is offset. So both emitters in the same position. We can see the particle sim looks like that. But how do we get it to follow the behavior of our sim, our fluid sim? So what we can do is create a dynamic relationship. And the way you do that is you can click on the object you want to link to a dynamic simulation, and we're going to go to the window relationship editor, and let's select the dynamic relationships window. And in this window we can indicate that we want our nparticle to be linked to the fields in our fluid shape. And that's all you have to do. You just have to select it once, make sure it's blue, and I'll just close that out. And in our nparticle shape, I mean, if we play this now, it won't look right. And that's because we have to turn off the velocity that's being used by the nparticles themselves. So let's just go into the nparticle shape, And I'm going to go into the dynamic properties of the end particles, and let's just take the conserve all the way down. And what this will do is prevent the particles from creating their own velocity and just rely on the velocity of the fluid simulation. So we can see it's already following the fluid sim, but it doesn't look that interesting, and that's because the emitter is just set to Omni. Let's change that to volume, and we're going to make sure we use a spherical volume, and let's look at that again. And we obviously need way more particles. Like if we look at the one in here, there's like millions of dots in here. It's just tiny, tiny bits of particles. And we need to add in a lot more. So I'm going to go back into the end particles emitter, and let's change the particle rate, the emission rate, to maybe 10,000. And at the same time, I'm also going to go and change our particle radius to be just a bit smaller, and let's see what that looks like. And we might need to go a bit smaller than that. Also, I'm going to hide the bounding box of this. So, there are particles being pushed around by the fluid. And you're probably wondering, why does it look so detailed? Like, why does it have so much more detail compared to the fluid sim itself? And that's because the particles are just being pushed around or advected by the velocity from that fluid simulation. So the more particles you push through here, the more they're going to gradually follow the fields, the velocity field from that smoke sim. So that's why we're getting all these interesting shapes. So, you could keep working on the fluid itself, and let's just turn on the velocity draw and see what this looks like. Yes, you can keep working on the fluid shape and add in as much forces and fields as you want, and that's gonna just it's gonna already be linked to the particle system. So you just make changes in the fluid shape when you want to change what's going on in the end particle system. So let's go back to our fluid shape, and I'm gonna go and check out the let's actually go back to the emitter. I'm gonna see if I can push some more force through this. Let's try 30 voxels a second. Now we should get something a little more powerful. And let's try breaking this up some more. I'm going to go into the fluid shape, and let's see what we can do in terms of turbulence. So I'm going to put in a bit of turbulence here. Let's set the frequency much lower and see how this breaks up. Might be a bit too much, but it's interesting. just see what a tiny bit of turbulence can do. I'm going to try to put some more particles in as well, just to make this a bit more detailed. Let's try maybe twice as much. And, that's essentially the main idea of building, structures like this. So if you have a fluid container and you create just a basic movement that you're interested in, capture the basic motion you're interested in, you can apply that to particles and create even greater detail. So, these effects range from creating plasma, creating ink-like effects, creating dust, atmospheric dust, dust particles. It's up to you, really. But I just wanted to share this cool technique with you guys and how you can drive a particle system with additional forces in the scene, including fluids. So maybe I do another video showing how to render this kind of stuff and get the kind of look more precisely. So just subscribe and comment and let me know if you're interested in any more topics like this one. And I'll provide the scene file that I used here, that I generated here, and any additional information. Just check the video description. So have a good one.